The story starts with a single system, the electronic medical records. Quite simply, it's an app that doctors use to digitize records for their patients. In health tech, things have grown quite a bit out of just medical records. Systems can cover more things that go on in the clinic, such as queuing, billing, and even lab and imaging for especially large clinics. The more general category is the health information system. Now, there is a well known problem in the health tech industry, the problem of interoperability. We have all these providers for health information systems, the market is saturated by it, but they don't share data with one another. Data becomes stored in individual silos. If you jump from one small clinic to another one just next door, chances are they'll be using a different system. You'll have to repeat your medical history all over again. There is no shareability because the systems in use are not interoperable. The logical solution would be to put a system, an interchange, whose primary function is to talk to systems in a standard way and act as an exchange for data. This is the health information exchange. Now, with the advent of Web3, a natural thought would be to put the health information exchange on the blockchain to incur the benefits of decentralization so that no single entity has control of all of the world's health information, and integrity, so medical data cannot be defrauded after they appear on the ledger. There's a problem with this though. Once something's on the blockchain, it becomes public and distributed to other nodes. Having a patient's prescription on the blockchain, for example, will open it up to everyone's eyes, which violates the patient's right to private health records. Our key breakthrough is to add in a layer of zero-knowledge proofs. These are small proofs of a fact, such as proof that a legitimate doctor prescribed you a certain medicine, for example, that leak no more information than is needed. You'd be able to verify, for example, that the patient does in fact have a prescription from a legitimate doctor, even if the details of the prescription or the doctor are hidden from you. So when it comes to the blockchain, only these zero-knowledge proofs are stored, not the actual medical information. Privacy is restored. We can go even further. Once we've established a blockchain-based protocol to share medical records that promotes both interoperability and privacy, we can start codifying the rules of consent and access to medical records with a system of smart contracts. So the benefits of decentralization and integrity can spread to different users' rights to medical records. Importantly, the patient, but also each healthcare provider's right to be granted access with the patient's consent so they can deliver better holistic care. This system, which is what we call HIPPR or the Hippocrades Protocol, solves the problems of interoperability, privacy, and medical data rights management in one fell swoop. This on-chain system of smart contracts called HIPPR, the Hippocrates Protocol, plus our set of system-agnostic REST APIs complete with zero-knowledge proof capabilities called Fleming, plus our suite of information systems called Curie, all together make up Hippocrates.
Let's go back to HIPPR, the Hippocrates Protocol. HIPPR is a system of blockchain smart contracts to govern medical record access rights, and of course, with the consent of the patient. In order to be precise with the access rights down to a user-by-user basis, we must represent each user with their own digital identifiers, or DIDs, courtesy of Atala Prism. In the real world, users can't just request access to a patient's medical records out of nowhere. Only healthcare providers are granted this right, and only on a need-to-know basis. This privilege is traditionally represented with a professional license, such as a doctor's license or nurse's license issued by the government. This is a great analog for the concept of verifiable credentials, also courtesy of Atala Prism. We can use verifiable credentials to bring the concept of professional licenses into the Web3 space, accruing the benefits of integrity, immutability, and decentralization, which is important when the credentials have the weight of granting rights to access patient medical records. To this end, we've integrated with Atala Prism so that Hippocrades can 1. Create digital identifiers or DIDs, 2. Create verifiable credentials, and 3. Verify an identity's credentials. We've accomplished this by creating a Prism middleware service communicating over an HTTP transport layer, and then integrating this middleware into our Fleming APIs. Through this, the app can now create both published and unpublished identities. With a published identity, using both the DID and the key pairs, the app can now also issue verifiable credentials. These credentials can be requested through the API in a format prepared for QR encoding, which can then be used to verify the credentials using another API call. For compatibility with other verification means, such as the Prism Verification web app, the credentials can also be rendered to other formats. Using these integrations, health facilities can achieve the setup described previously, with doctors, nurses, and other healthcare providers all receiving verifiable credentials based on existing traditional credentials, such as licenses to practice medicine, to attest to the veracity of the medical records they create. Health facilities themselves can also be issued verifiable credentials so that they may be verified to operate, as well as to qualify them for being granted access to a patient's records in the interest of better patient care.